Hello student, how are you? I hope you all are fine. So students, subscribe my YouTube channel so you don't miss out the upcoming content. Today we are going to discuss here one of the problem related to projectile motion. That problem had been asked in JEE Advanced Examination in 2025. So before solving this problem, I want to elaborate the topics that involved here and also explain here the concept of safety parabola. So we have to understand here what is projectile motion. So when the any object is projected with some angle, some velocity with the horizontal, so the path taken by this object would be curved and the part will be parabola, and this on during the motion of the object in parabolic path, the gravity is acting in downward y direction, downward on while the object is moving up or down, the gravity is always acting downward, and we assumed here that there is no air viscosity, no friction of air. So we assumed here the velocity is component of velocity in x direction remains constant. So we can write here the uh, parabolic equation and the time period, flight time, time of flight, and maximum height and range. The formula would be, so the trajectory equation will be x tan theta 1 minus x upon r, where x and y is the coordinate on the parabolic path. So when we project this object in this path, this is the, suppose this is the initial angle u and this is angle theta, then this height would be maximum height, and this would be the range from here to here. This would be the range, and the from movement here to here, the this is flight, time of flight from A to B. So this is time of flight to A to B for the motion. So the, if assumed we, the there is no friction in atmosphere, so we assume this is the u cos theta, and this is ux, and this would be uy, this would be u sin theta. So the component of the velocity of the horizontal direction not change. So this velocity would be u cos theta, always ux is constant if we assumed there is no friction in air, and the velocity of the v sin theta, v sin this component u sin theta changes here. So we assume that the projectile here, the angle make that is phi, and this velocity becomes v. So we calculate the v sin theta. This would be different in y direction. We apply the kinematics equation. So we get the height would be u square sin square theta over 2g, and the range would be, what would be range? Range would be x ux into time of flight. So range would be u square sin 2 theta, sin 2 theta over g, sin 2 theta over g. This is the range, and time time of flight would be 2u sin theta over g. This results can be obtained by the kinematic equation on applying in this projectile motion. So this is the equation of parabola. We also write the parabola equation would be x tan theta minus gx square upon 2u square cos square theta. This is the equation of parabola. The here x square, here the term, this is minus x square, so this is downward parabola. For the downward parabola, this equation is downward parabola, and we also write here r theta upon r minus 90 minus theta would be 1. So this means if we project a object either the angle theta or 90 minus theta, the range would be the same. And we write here t theta, t 90 minus theta would be tan theta. And we write here as theta upon h 90 minus theta would be tan square theta. When we placing the value theta and 90 minus theta in this equation and solve out the getting the result tan square theta and for time period the tan theta. So we write here as theta into as theta plus as 90 minus theta would be H maximum. What is H maximum? H maximum is u square by 2g. This is maximum height. So H maximum would be h square minus h square by 2g. And we write here as theta into h 90 minus theta. This would be r by 4. R is the range. So this would be r by 4 and d theta into t 90 minus theta would be 2r by g. R is the range. So this is the result and we when we take a projectile and we take suppose this is a projectile here and we take here the scenario is this. If we take this is a projectile angle, suppose this angle making angle theta and this is the coordinate x and y here and this coordinate is making suppose alpha and beta angle. So we can write here tan theta is equal to tan alpha plus tan beta. This is also a result. So we discuss here safety parabola. What is safety parabola and what is utilization for the safety parabola? So we take here, suppose in this region, this is a origin here, and a gun is firing the bullet here, here, and here, and here, with the initial velocity u. The velocity is fixed here, and we firing the bullet from here to here and here to here, and this bullet is firing in xy plane only, not 3D plane. So the trajectory would be this bullet is firing upside, so the trajectory would be this side, and the bullet is firing in this side. Suppose this is bullet is this side, so trajectory will be this side, and when bullet is firing this side, so trajectory would be this side, and when bullet firing this side, trajectory would be this side. Suppose this is the trajectory, and we take it similarly here. This would be trajectory, this would be trajectory, this would be trajectory. So different trajectory is here. So you observe here the initial velocity of firing the bullet in this plane, this is xy plane, is same. Initial velocity is same. Suppose we we have to find the region where the we have to find the region where the a suppose this is a suppose we assume here this is a envelope here, suppose this is an envelope here, and we suppose this is an envelope here, this is envelope here, this is an envelope here, imaginary envelope here. In this region, beyond this region, the bullet is either just grazing this region or inside this region. The bullet is either inside this region or grazing this region. Bullet is inside the region or grazing this region. This bullet is just inside and grazing the region. So we have generate a equation here for safety parabola. This region would be say safety parabola. This region says as safety parabola. So what is safety parabola? We know the equation of the parabola. We suppose here the point is xy, and for this point and for this point, see over here 2 points, we take this point and take this point. So on at this point the coordinate is x and y, and on this point we two two types of bullet strike on this point. So this type and this type, here to here and here to here. So two types, two way to apply here the bullets. So two angle of theta is responsible. This is theta 1 and theta 2 angle is responsible to strike this point. So this point would be lies in the safety parabola inside, and only one point. This is only one point. Strike here. This exists on a safety parabola. Only one point for this. Only this bullet strike on this point. This bullet just grazing this safety parabola. So what is safety parabola? So equation of parabola. So equation of parabola we can write here. This is x tan theta minus gx square 2u square. This becomes sec square theta. We write here 1 plus tan square theta. So we write here tan square theta gx square upon 2u square. This is tan square theta minus tan theta into x. This will be minus and plus. This would be y plus gx square upon 2u square equal to 0. So see over here, here the theta is variable. So theta is variable here. So we write here a tan square theta. This is quadratic in theta plus b tan theta plus c is equal to 0. So this is the quadratic in the form of theta. So if discriminant is greater than 0, then these points lies between here. So tan theta have the two value. So see over here, tan theta have two value, theta 1 and theta 2. So tan theta have two value, tan theta having two roots, two value. So real and unequal value here. The theta 1 is differ and theta 2 is differ for this point. If discriminant is greater than 0, if discriminant, that is b square minus 4ac, is equal to 0, then theta would be unique value. So theta would be unique value, and real value, unique and real roots will be equal. So theta would be fixed here, any one angle. So this is the equation of safety parabola. So we write here b square minus 4ac for a single value of theta here. Here the theta having two value. So b square minus 4ac. Write here b square minus 4ac. So this is a, and this is x is b, and this term is c. So what is b square minus 4ac? So this becomes x square minus 4 gx square upon 2u square into y plus gx square upon 2u square is equal to 0. So on solving this, so this would be x square, and this would be 2 to cancel out. So this becomes x square, this is u square upon gx square is equal to gx square 2u square plus y. So on shifting this term, so x square cancel, and this is 2u square, this is 2 gx square. So this becomes y becomes, so right here y becomes u square by 2g, u square by 2g minus gx square upon 2u square, gx square upon 2u square. This is the equation of the safety parabola. So if we, for practically we understand this phenomena, suppose here we take two examples here to understand this phenomena. Suppose here any object, any ball is, and this is a ball here, and this is a x length distance here, and this length is fixed, and the velocity u is also fixed velocity here, and this is angle theta. So here we have to find the maximum y maximum. So what is the maximum height of the wall? So this ball strike on this wall. So for y maximum, we have two ways to find the y. Here y is variable, so we find dy over d theta, dy over, we we know the equation of the parabola, that is y is equal to x tan theta minus gx square upon 2u square cos square theta. So we differentiate y dy by d theta and place the, and equate it equals to 0, and find the value of theta and place in the equation of the uh, parabola, and placing the value of x and finding the value of theta, and then finding v maximum. But from here we easily find, this is the, this point must be lies on, this point must be lies on the safety parabola. This point must be lies on the safety parabola. So we know the equation of safety parabola. So we placing the value of u and x, u and x here. So find the value of y maximum we have to append here by the equation of safety parabola. We don't have to do the writing the equation of parabola and differentiate the equation of parabola with respect to theta and equate it 0, and when finding the value of theta and then placing the value in theta in the equation of parabola. This is the another way, and this is also the shortcut way. By this we have to find the equation. So another question, in this question, suppose this is a inclined plane, and here an object is hitting, and this length is, suppose this is 4, this is 4, this is suppose 3, and this is 4. So coordinate will be here, this is suppose origin 0 comma 0, so coordinate can be right here 4 minus 3. This is the coordinate here xy, and we have to find here the initial velocity of u, so that this, suppose this is a ball and this ball hit here, hit this edge. So we have to find for this, so this point would be lie on the safety parabola. So placing the value of x and y in this here and finding the velocity of u easily. So y would be what? Minus 3, and u square and 2g becomes 20 minus 10 x square is 4 square 16, and 2u square 2u square. So this becomes 5, this becomes u square by 20, and this becomes 80 upon u square minus 3. So we write here u raised power 4 minus 1600 upon 20 u square. So this becomes u raised power 4 minus this becomes plus, this becomes plus 60 u square minus 1600 is equal to 0. So let u square is equal to z. So z square plus 60z minus 1600 becomes 0. So applying Siddharachar, minus 60 plus minus under root 60 square minus minus plus 6400 and upon 2a, this is 2. So this becomes, z becomes minus 60 plus minus 60 square 3600 and 6400, this becomes 100. 10 raised to power 4 becomes this. So this becomes 100. So this becomes, taking positive sign, so 40 upon 2, this becomes 20. So what is the value of u? U would be under root z. So this would be 2 root 5. So this is the velocity. Velocity would be 2 root 5. So this would be 2 root 5. So this is the question asking here, and one question also generate here. Suppose if a plane is flying from a particular height, so this height would be, the particular height should be the less than the maximum height, that is u square over u square by 2g. Suppose here the point is here, and here the in midpoint a gunner is stated here, and he is regularly firing in xy plane, and this is the point where the, this is aeroplane here, aeroplane is flying here to here. So we have to find the time of flight in danger zone, in danger zone. So in this we have to given the flight of the air, this is aeroplane here. So the flight of aeroplane, this is v, velocity of aeroplane is v, speed of aeroplane is e. We have to find this region. So this region would be lies in the safety parabola. In this region, the distance here to here, this is the, here y is fixed, and this is the distance x. We have to calculate here x, and we have given the velocity of the, this is the velocity of the bullet, this is given in question. This is velocity of the bullet here, and this is distance x. This distance we have to calculate. We have given y and u is given, so we have calculate x here. So we, this is x and this is also x. So 2x would be the total distance of danger zone. So time period would be 2x upon v. So on placing the value, question in given question, the values are given, would be given according, we placing the value in equations and get the answer. So this is the problems from safety parabola, and we have discussed here the problem that has been asked in IIT JEE advanced examination. In this problem a projectile of 200 gram is launched in a viscous medium at an angle of 60 degree. So here the, see you here, this is a projectile, and this is a projectile of 200 gram. This is a mass, the mass having m is equal to 200 gram is equal to 2 kilogram. So and this is the initial velocity u is equal to, given 270 meter per second. This is u, and theta is given 60, theta is given 60 degree, the angle 60 degree, and here the experience a viscous force. So in this x direction, y direction gravity is acting, but here the x direction, the layers is here, the layer of air is here, the viscous force is acting. So when the projectile moves here, this is the path of projectile, and this is the wall, and this is wall, and we have to reach the instantaneous velocity. Suppose this is the point V here. This is the point where the velocity is in instantaneous, and the projectile hits a vertical wall after 2 seconds. So here to here the time is 2 seconds, and value of E is given. So we have to calculate this length, this distance, horizontal distance. We have to calculate this horizontal distance. So what we say here, so the ux would be in this direction, initial velocity ux would be u cos 60 degree, and u is 3 270 on cos 60 is 1 by 2, so this becomes 135 meter per second. And here the velocity, suppose this is velocity is v here, and the in this direction, this suppose this angle is phi, so this direction is velocity is vx, component of velocity is x. So net force, here net force is not only gravity, here net force is two type. F net would be d, been right here, m into a acceleration, so dv over dt, this is acceleration. So F net would be, this is acceleration. So F net would be what would be F net? F net would be mg. F net would be mg plus, this is gravitational force. We write here, this would be Fg, gravitational force, plus viscous force. This is Fv is equal to m. So we write here m dvy over dt plus m dv x over dt. So on equating, so we write here dv is equal to m dvx. So we write here fv is equal to m dvx by dt. So fv would be, fv is given minus cv, v vector. So minus cv is the here given. So what is the value of m? M is equal to zero point 0.2 and dv over dvx over dt. So we taking only magnitude. So what is the value of c? C is 0 0.1. C is 0 0.1. So this becomes minus 0 0.1. This is 0 0.2. So this becomes v is equal to dvx over dt would be minus v by 2. This would be minus v by 2. So we write here dvx by v. This is vx. This is vx. dvx by vx, and this will be minus 1 by 2 dt. So we integrate this 0 to t, initial limit 0 to t. Here the time is 0, here time is t. So we have to, here we placed here the velocity of, here the velocity is 135 and final velocity is v. So this will be 135 initial limit. The initial horizontal velocity is 135. A final velocity is vx. So this would be vx. So what is the integration? This would be log vx and vx by 135. This becomes minus t by 2. So we write here, this would be natural log vx by 135 is equal to minus t by 2. So we write here vx is equal to e raised to power minus t by 2, and this would be 135. On again integrating, so we write here this is dx over dt is equal to 135 e raised to power minus t by 2. So this would be dx 135 e raised to power minus t by 2, and this would be, this is minus sign here, this minus sign is helpful. So this will become dt. So time is 0 to 2 second and distance is 0 to x. So x would be, so this becomes 135 into e raised to power minus t by 2, and the minus t by 2, the integration of e raised to power minus t by differentiation of minus 2, this becomes minus 2 minus 1 by 2, 2 becomes upside, and limit 2 to 0, and this becomes 170, 270, 270 minus, and this becomes e raised to power minus 1 and e raised to power 0, this becomes 1, e raised to power 0 is 1. So this becomes minus 270 upon 1 by e, 1 minus e upon e. So value of e, the value of e is given 2.7. So placing the value here, minus 270, 1 minus e, so this becomes 1 minus 2.7 upon 2.7. So this becomes minus 270 minus 1.7 upon 2.7. So 17 upon 227. So this becomes 170. Minus minus becomes plus. So this length would be 170 meter from this wall. This is a wall. So this is problem has been asked in IIT JEE Advanced in 2025. So I solve here. So I hope you enjoyed this session, and by this approach I discuss here, your mental endurance would be increased. And so thanks for watching this video and take care.